For most of human history, Mars has been a symbol, a red dot in the sky, a dead world, a reminder of what happens when a planet loses its future. Cold, dry, frozen in failure. That image has shaped everything, from science fiction to serious planetary science, but recently something unsettling happened. Not through a new rover, not through a dramatic announcement, but through quiet computation. As AI systems began rebuilding Mars's ancient past, from fragments of data, broken terrain, mineral traces, erosion patterns, a different planet started to appear. Not a wasteland, a system, a planet that once behaved less like a corpse and more like a world that was alive. And once you see that version of Mars, a new question becomes unavoidable. If a planet can change that completely, what does that say about ours? Stay with me. Because by the end of this episode, Mars won't feel distant anymore. It will feel uncomfortably familiar. Mars has always been easy to categorize, a planet that failed. Its atmosphere stripped away, its water vanished, its surface locked in rust and dust. We learned to think of it as a warning sign, a planetary graveyard orbiting just far enough away to observe, but not to fear. And for decades, that story held. Scientists mapped dry riverbeds, identified ancient impact scars, confirmed that whatever Mars once was, it was gone. But there was always a problem. The data didn't fully agree. Some valleys were too complex to be carved by brief floods. Some mineral deposits required long-term water interaction. Some erosion patterns didn't fit a simple, wet then dead narrative. Individually, these anomalies were explainable. Collectively, they were inconvenient. Human researchers did what humans always do when complexity overwhelms intuition. They simplified. Mars became a planet that had water briefly, then lost it. A short story, a neat ending. And then AI entered the picture. Not to look for life, not to speculate, but to do something humans struggle with: hold all the data at once. Instead of asking AI to find something on Mars, scientists asked a different question. What if we let the machine reconstruct the planet itself? They fed models everything: orbital imagery, topography, mineral spectroscopy, crater distributions, sediment layering, climate simulations spanning billions of years. Not in isolation, but together. This mattered, because AI doesn't need to reduce complexity to survive it. It doesn't get tired. It doesn't favor clean narratives. It looks for coherence. And when these systems began running backwards, inferring ancient conditions from present-day scars, Mars stopped looking simple. River networks expanded into continental systems. Lakes connected into basins that persisted far longer than expected. Atmospheric models stabilized instead of collapsing. The machine wasn't finding moments of habitability, it was reconstructing duration. Mars didn't just flirt with being Earth-like, it sustained it. And that changes something fundamental. Because a planet that sustains water, climate cycles, and surface stability isn't just capable of life, it behaves like a living system. At this point, the discovery stops being about Mars. It becomes about planetary memory. AI wasn't imagining a different Mars. It was reading what the planet had been trying to tell us all along, written into its surface, waiting for something capable of understanding scale without shortcuts. The reconstructed Mars that emerges from these models is unfamiliar, not blue, not green, but active. Seasonal flows, shifting shorelines, atmospheric feedback loops that dampened extremes instead of amplifying them. Mars didn't collapse overnight, it drifted. And that matters because drift feels safe until it isn't. Here's the uncomfortable parallel. Earth is drifting too, not toward lifelessness, but toward instability. Climate systems nudging out of equilibrium. Feedback loops slowly reversing sign. Changes that don't feel catastrophic year to year, but compound relentlessly. The same AI tools used to reconstruct Mars are now being applied to Earth, to climate forecasting, to ecosystem modeling, to long-term infrastructure planning. And they're revealing something unsettling. Planetary collapse doesn't announce itself. It normalizes. Mars didn't die screaming. It faded quietly, while still looking functional, which raises a human question we rarely ask. Would we recognize planetary failure while living inside it? AI doesn't see nostalgia. It doesn't care what we're used to. It sees trajectories. And when it compares Earth's current trajectory to Mars's ancient one, the comparison isn't comforting. Not because the outcome must be the same, but because the process is. Mars wasn't doomed. It was unmanaged. Here's the shift this discovery forces. Mars isn't a symbol of inevitable failure anymore. It's a case study, a planet that once functioned and then crossed thresholds it couldn't return from. And the only reason we can see that now is because AI can reconstruct what humans never witnessed. Which brings the question home. If AI can read the long memory of a dead planet, what will it say about the living one we depend on? The power here isn't prediction, it's perspective. For the first time, we're not guessing what planetary futures look like. We're comparing them. Mars becomes a mirror, not of destiny, but of consequence. And unlike Mars, Earth has something Mars never did. A species capable of understanding the warning in time. AI isn't telling us Earth will fail. It's showing us how failure unfolds when no one intervenes early enough, quietly, gradually, normalized, which reframes the real discovery. It's not that Mars was once more alive than we thought. It's that planetary stability is far more fragile and far more precious than we realized. There's one final implication hiding inside all of this. Planets don't just change, they remember. Every atmosphere lost, every ocean evaporated, every feedback loop that tipped too far, it all leaves signatures behind, not as stories, but as structure. Mars didn't forget what it was. We did. And it took a non-human intelligence to read those memories without bias, without mythology, without comforting narratives about inevitability. That's the real shift. For the first time, a species can compare its present trajectory against a complete planetary past, not imagined, not simplified, but reconstructed in full. Not as a warning shouted, but as a pattern revealed. And patterns, once seen clearly, are hard to unsee. I used to think Mars was interesting because it was dead. Now I think it matters because it lived, long enough to leave behind a warning. And for the first time, we're intelligent enough to read it. If this changed the way you see Mars and the quiet signals planets leave behind, hit like. It helps more people understand what's already written into the world around us. Subscribe to become part of the Unlocked and join us each week as we explore the discoveries reshaping what it means to be human and what it means to survive. If someone you know still thinks Mars is just a dead rock, share this episode with them. Because sometimes the most important discoveries aren't about the future. They're about recognizing the past before we repeat it. Because the future isn't coming, it's already here.